Actually, flowing highly reactive. oxygen liberates both. So balance reaction. So 10HF, 5F2. Now in this reaction, oxidation state of chlorine. Chlorine oxidation state always decreases from 0 to -1. But oxygen oxidation, it increases from -2 to 0. It is oxidation. It is oxidation. Now in this reaction, chlorine acts as oxidizing. So in this reaction, chlorine oxidizing oxygen oxide -2 to 0. So in this reaction, chlorine oxidizes oxygen from -2 to 0. This is an exception. Strong oxidizing from non-oxidizing strong oxidizing strong oxidizing ability of oxygen or chlorine. So in this, chlorine is acting as oxidizing agent. It oxidizes even oxygen also from -2 to 0 state. Suppose if you go for the same reaction with chlorine, chlorine reacts with water, forming HCl plus HOC. Here, chlorine oxidation number decreases from 0 to -1, from 0 to +1. It is reduction part. This is oxidation part. So in this reaction, chlorine is disproportionated. Chlorine is disproportionated. The same element undergoes both oxidation and reduction, what we call disproportionation. So here chlorine is disproportionated. So when chlorine is passed into water, what are the products? Hydrochloric acid and hypochlorous acid. And you all know hypochlorous acid is unstable. So it readily decomposes, giving nascent oxygen. Thus, chlorine in the presence of moisture acts as oxidizing agent. Why not moisture? in the presence of water, how it acts as oxidizing agent? So the answer is, it is forming HCl and HOCl, and then HOCl is giving out nascent oxygen. That's why chlorine in the presence of moisture acts as oxidizing agent. You all know the municipalities, when they treat water for drinking purpose. If you observe any municipal water treatment plant, there the water is treated with chlorine gas. So you see yellow color cylinders. Next time when you go and observe the municipal water tanks or water storage facilities, where it is used for drinking water, for circulating for the people. So what they do, they keep some yellow color cylinders on the bank of the water tank, and which chlorine gas is passed into that. So when chlorine gas is passed into it, what are the two substances liberated? HCl and HOCl. HOCl further breaks into HCl plus nascent oxygen, and this nascent oxygen kills all the bacteria. It kills bacteria. So you can say chlorine acts as a sterilizing agent for water. Chlorine acts as a sterilizing agent for water. Then some of you may ask a doubt. If it is acting as a sterilizing agent, along with HCl is also produced, is this HCl harmful to us? Yes, that is a relevant question to be asked. For that, the answer is, HCl is also secreted in our stomach. So the water which we are drinking contains very small quantities of HCl, and our stomach also secretes HCl. So it is a similar acid produced in the stomach. So we don't have any problem. Moreover, it is in a diluted condition, not too much concentrated. So this is about chlorine and water reaction. So now we already completed the reaction of halogens in water, chlorine and chlorine. So now bromine. Actually, as we come down the group, the water solubility decreases. Bromine slightly dissolves. It has very less solubility. Slightly dissolves and forms HBr and HOBr. Hypobromous acid. Of course, this is also not stable, and it also gives off HBr plus. But this reaction we don't use for sterilizing water, because HBr is a strong acid which our stomach cannot bear. That's why only chlorine is used for sterilizing water. Now in case of iodine, it has no water solubility, insoluble in water. So iodine is not soluble in water, but in the presence of Kn, iodine is soluble in water. This is very important. put asterisk. So the solubility of iodine in water is enhanced in the presence of Ki. Then what is the reason for it? Ki and iodine reacts and form a water soluble compound called Ki3, potassium triiodide. So why water solubility of iodine increases in the presence of aqueous Ki? Because you are getting a soluble compound. What is that soluble compound? Potassium triiodide, Ki3. Now I will ask here, what is the shape of actually Ki3? Is K plus I3 minus. Now what is the shape and hybridization? I minus of I minus. So actually I minus, three ions are linked with each other. This is the central atom. Central atom has two bonded atoms. The bond pair is equal to 2. Lone pair is equal to. Total valence electrons of central atom. Iodine has 7 electrons. Minus means 1 electron added. 8 minus. 2 ions contribute 2 bonds. So this is the formula for lone pairs. The total number of electrons in the central atom. How it become 8? 7 valence electron minus 25 plus minus means 1 electron has been 8 minus 2 ions are formed 2 bonds. So it is 3 lone pairs, 2 bond pairs. So total 5 pairs. Total pairs is equal to 5. Means sp3d hybridization. Though it is sp3 hybridization, it is not a trigonal bipyramidal. It is linear. I3 minus is linear in shape. Now these are the 3 lone pairs. So 3 lone pairs occupy 3 equatorial positions. 2 bond pairs axial positions. Overall 3 ions are linearly arranged. What is the type of hybridization? sp3d. So this is about reaction with halogens reaction with water. So when halogens are reacting with water, slowly, when reacting with water, it is forming or liberating ozone plus oxygen plus ozone. When chlorine is reacting with water, it is forming HCl plus HOCl. Bromine also same. HBr plus HOBr. Iodine is insoluble in water. So down the group, water solubility decreases. Down the group, water solubility decreases. So this is our conclusion. Next, third reaction. Reaction with alkalis. Halogen reaction with alkalis. Now, if you take this as an example, sodium hydroxide plus fluorine, condition A, condition B. Sodium hydroxide plus fluorine, there is one more condition. The first condition is cold dilute. The second condition is hot concentrated. You can call this as one set of reaction. In cold condition, you get NaF plus OF2 plus H. Sodium fluoride plus oxygen dichloride plus water. In hot concentrated condition, this is the condition. Now, you can balance this reaction. Writing 2NaOH, 2NaF, or 2H2F, 2Na. This is balanced. Now this one. Write 2H2, 4NaOH, 4NaF, 2Na. Now in these two reactions, fluorine is always undergoing reaction. Fluorine always undergoes reaction. When it is undergoing reaction, it is acting as oxidizing agent. It is acting as oxidizing agent. So fluorine always undergoes reaction. Means it always acts as oxidizing agent. Now, fluorine, bromine and iodine, they react in different ways under these two conditions. So one is cold dilute, the other is hot concentrate. This is one set. In cold dilute, fluorine forms Na is here and NaO is here and H. Sodium chloride, sodium hypochlorite. Here it is sodium chloride and the sodium chlorate. Sodium chloride and sodium chlorate. Actually, these two you have studied in your 11th class in the properties of NaOH. NaOH properties, these two you have studied. Now you balance this reaction. These are the balanced reactions. Now in both these reactions, fluorine is undergoing disproportionation. 0 to -1 and 0 to +1. Here also it is 0 to -1 and 0 to +1. Chlorine is undergoing disproportionation. But fluorine always undergoes reduction. It always acts as oxidizing agent. Then you may ask me, what about bromine and iodine? Br2 and I2 react with alkalis in a similar way like chlorine. So if you write with Br2, what are the expected products? Br2 and cold dilute alkali. Instead of NaCl, we get NaBr, NaOBr and H2. If it is hot concentrated, 3Br2, here 5 NaBr, NaBrO3 and H2. This is sodium chlorate. Suppose if it is iodine, sodium iodide and sodium iodide. Sodium iodide and alkali in hot concentrated condition. Sodium iodide and sodium iodide. Means iodine and bromine also undergoes disproportionation. Only chlorine also undergoes disproportionation. Fluorine always undergoes reduction. So this is a reaction of alkalis with halogens and alkalis. One halogen is undergoing reduction, the remaining 3 halogens are undergoing disproportionation. Now, next reaction, fourth or fifth, whatever it is, reaction with metals. Now, this is very simple to predict because metals are highly electropositive. Metals are highly electropositive. Halogens are highly electronegative. When a highly electropositive metal reacts with a highly electronegative non-metal, the bonds formed will be predominantly ionic. So you get ionic compounds. Look at this. Fluorine plus sodium. You get sodium fluoride. It is an ionic compound. Or magnesium plus fluorine. MgF2. Ionic. Or sodium plus chlorine. Sodium chloride. Ionic. So metals and fluorine are predominantly metal plus halogen. The compounds are predominantly you will get ionic compounds. Ionic compounds. So why am I using the word predominantly? Why can't I use? They totally form ionic compounds. Write the reason. Among halogens, iodine has the largest size. When halogen has largest size, the halide ion is more polarizable is more polarizable. If the negative ion is more polarizable, if the positive ion is having more polarizing power, so high polarizing power of cation, that is positive ion, high polarizability of negative ion, so high polarization of cation, that is positive ion. High polarizability so when polarizing power of cation is high, polarizability of anion is high. As per Fajol's rules, the compound form will be mostly covalent in nature. So write a question here. Why lithium iodide is covalent? Why lithium iodide is covalent? The answer is Li plus is a very small cation. Means high polarizing power. And I minus, which is a very large anion, which is strongly pull the negative charge. So it is having high polarization. So small cation is having more power to pull the negative charge, that is called polarizing power. The negative ion has a tendency to shift its electron cloud towards positive ion. It's called polarization. A high polarizing power and high polarizability always has covalent character. That's why lithium iodide is covalent. Okay, sorry for this small interruption. So why lithium iodide is covalent? Just now I cleared because of high polarizing power of Li plus and high polarizability of I minus. Now reaction with non-metals. reaction with non-metals. Since halogens are non-metals, if they combine with other non-metals, obviously the compound formed will be covalent. So, if you react phosphorus and chlorine, 2p plus 3Cl2, 2PCl3, phosphorus trichloride, if it is limited chlorine. Suppose same phosphorus with excess of chlorine, 2PCl5. So PCl3 and PCl5 are covalent compounds. So whenever halogens react with other non-metals, what the type of compounds formed? Covalent compounds. You all know chlorine is highly reactive. That's why it reacts with xenon also and form xenon difluoride or xenon tetrafluoride or xenon hexafluoride, XeF6. For all these high temperature and nickel catalyst is required. Now if it is xenon difluoride, xenon tetrafluoride is 2F, here 3F. So these are all xenon compounds, xenon fluorides, xenon difluoride, xenon tetrafluoride, xenon hexafluoride. Write a question. What is the type of hybridization of xenon? What is the type of hybridization in xenon in its fluorides? So if you take all the xenon fluorides, XeF2, xenon is the central atom. It is connected to how many fluorines? 2 fluorines. So just by number of bond pairs, since it is connected to 2 atoms, bond pairs are 2. What is the formula for number of lone pairs? Valence electrons of the central atom. Xenon has 8 valence electrons. You all know that inert gases have NH2 NP6 configuration in their valence shell. So NH2 NP6 is 8 electrons. Minus 2 fluorines form 2 bonds by 2. So 3 lone pairs. Just now we completed. When the total pairs are 5.
sp3d.
sp3d hybridization. And the shape is, though the expected shape is trigonal bipyramidal, but the observed shape for xenon difluoride is linear because it has 3 lone pairs, 3 LP, 2 BP, total 5 pairs. Xenon is what type hybridized? sp3d. If it is sp3d, why shape is not trigonal bipyramidal? Because 3 lone pairs are occupying on the 3 corners or equatorial positions of xenon, and 2 fluorines are occupying the axial positions. Bond pairs only determine the shape, so it is linear. XeF2 is linear. Now can I say XeF2 and I3 minus XeF2 and I3 minus XeF2 and I3 minus are isostructural. Or isostructural. Is it a correct statement of constitution? XeF2 and XeF2 I3 minus. Both are linear. That's why they are called isostructural. They have same structure. Isostructural. Now, if you go for XeF4, XeF4, here xenon is the central atom, and 4 fluorines are bonded atoms. The central atom is connected to how many bonded atoms? 4 bonded atoms. So bond pairs are 4. Now lone pairs.
1.
We apply the same formula for lone pairs. Valence electrons in the central atom 8 minus number of bonded atoms is equal to 4 by 2. 2 lone pairs. When 4 bond pairs and 2 lone pairs are there, the shape will be square planar.
Square planar.
So total 6 pairs, bond pairs 4 PP and 2 LP, total 6 pairs, means it is sp3d2. Though it is sp3d2, it is not octahedral because of lone pairs, and it gets a shape called a square planar. So xenon tetrafluoride is a square planar molecule. It has 4 bond pairs, means 4 bonded atoms, 2 lone pairs. Now if you check XeF6, now I am changing to the last one. So bonded central atom is xenon only. Bonded atoms are fluorines. 6 fluorines are bonded, so 6. Lone pairs 8 minus 6 by 2. So the lone pairs become 1. So total pairs 6 bond pairs and 1 lone pair, 7 pairs, sp3d3. Though it is sp3d3, we expect a shape of pentagonal bipair. But one of the problems is occupied by lone pair. So its shape is distorted octahedral. Distorted octahedral. octahedral. This is about XCF6. So, we have completed the shapes and hybridization of xenon fluorides, which are very important for the examination.
Sir, your voice is not clear.
Which one? Voice. Now is it clear?
Yes, sir.
So when sulfur reacts with fluorine, form SF6. Now is it clear? Sulfur hexafluoride. Why SF6? Why SF6 do not undergo hydrolysis? Why SF6 do not undergo hydrolysis? For this, the answer is whenever fluorine connects to any atom, it forms strong covalent bonds. So SF6 has a regular octahedral geometry, a very stable molecule. Because of its stability and strong bonds formed, because of its stable geometry and strong sulfur fluorine bonds, it is quite inert in nature. So SF6 do not undergo hydrolysis. Now if you take some of the special properties of fluorine, Chlorine reacts with carbon monoxide in the presence of sunlight, forming carbonyl chloride. Which is also called phosgene, a poisonous gas. So its structure will be two chlorines attached to carbon with one double bond. That is the structure carbonyl chloride, which is also called phosgene. This is one of the important extra property of chlorine. Similarly, chlorine also reacts with nitric oxide and form nitrosyl chloride. Here itself we mention one more point. Nitrosyl chloride, which liberates nascent chlorine, is mainly responsible for nitrosyl chloride, which liberates this nascent chlorine, is mainly responsible for dissolution of gold and platinum. Dissolution of gold and platinum in aqua regia. in aqua regia. Aqua regia means concentrated HNO3, one part, and concentrated HCl, 3 parts. When you mix these two concentrated acids, HNO3 and HCl in 1:3 ratio, that medium is called aqua regia. That aqua regia also produces nitrosyl chloride. Because of this nitrosyl chloride, which is liberating nascent chlorine, gold and platinum are soluble in aqua regia. So, which is mainly responsible for the dissolution of gold and platinum, which are called noble metals. Generally, gold and platinum do not react with any other acids, but they dissolve in aqua regia. What is meant by aqua regia? These two acids, concentrated HNO3, concentrated HCl, in what ratio? 1:3 ratio is called aqua regia. Aqua regia also produces nitrosyl chloride, which in turn gives chlorines. These nascent chlorines are responsible for dissolution of gold and platinum in aqua regia. In the 16th group, we already discussed the ozone layer in the stratosphere is depleted because of nascent chlorine. There the nascent chlorine is liberated from or liberated by chlorofluorocarbons. Chlorofluorocarbons, CFCs. So that is the reason. Now, if you go for other properties of chlorine, in the first year, you are studying this, 11th class. Methane plus chlorine, sunlight. What is the end product? So the answer is CCl4, carbon tetrachloride plus 4HC. What kind of reaction is this? Free radical substitution. So methane reacts with chlorine in the presence of sunlight. What is the final product? Carbon tetrachloride. Actually, this is a free radical substitution reaction, FRS. Similarly, fourth one. What is the reaction between benzene and chlorine in the presence of sunlight? Benzene plus chlorine in the presence
Chlorobenzene.
the 3 pi bonds of the benzene. For each pi bond place, 2 chlorines are added. This pi bond will have 2 more chlorines added. This pi bond contributes 2 more chlorines. So total 3 moles of chlorine reacts. And you know each carbon is already connected with 1 hydrogen. Benzene is already having each carbon connected to 1 hydrogen. That's why finally the C6H6 benzene is converted to C6H6Cl6. It is called gamaxin. Insecticide. It is an insecticide for killing ants, for killing mainly ants and other small insects. We use gamaxin. You know, gamaxin is also called lindane. The other name is LINDANE. It is also commercially called as 666 because 6 carbons, 6 hydrogens, 6 chlorines. For same benzene, to treat chlorine in the presence of anhydrous aluminum chloride. You will get chlorobenzene. Chlorobenzene. So, chlorine in the presence of sunlight gives benzene hexachloride. It is also called BHC. Benzene hexachloride. BHC. So, chlorine sunlight, you will get benzene hexachloride. Whereas it is good, but only thing is markers can use. Markers, please. So, what is the next reaction for? With chlorine in the presence of anhydrous aluminum chloride.
Sir, your voice is not clear.
Recording this sound, it is causing some good sounds.
Sir, your voice is not clear.
No, it will. Now it is okay. Just a minute. So, see the second part of the reaction, where chlorine and anhydrous aluminum chloride, you are getting chlorine. This is EAS, electrophilic aromatic substitution. This is benzene hexachloride. Here each pi bond place chlorine chloride. So this is addition reaction. But here one place, in the place of hydrogen, one chlorine is substituted. It is substitution. What kind of substitution? Electrophilic aromatic substitution. Benzene always undergoes EAS type of reactions. Benzene always undergoes EAS type of reactions. Rarely it undergoes addition reactions. Why benzene prefers to undergo substitution rather than addition?
If it undergoes addition reaction, it loses its aromaticity.
Very good. Excellent. That is correct answer. So if it undergoes addition, the pi bonds will be gone, 3 alternate pi bonds. Thereby it loses the property of aromatic character. Aromaticity is one of the contributing factors for the stability of benzene. So benzene don't want to lose its stability by losing its aromatic character or delocalization of pi bonds, because 3 alternate pi bonds in benzene is called delocalization or resonance. Because of 3 pi bonds alternatively arranged, the phenomenon is called resonance. Benzene gets stability. So by undergoing addition, it don't want to disturb its pi bonds. That's why benzene want to undergo substitution. What kind of substitution? Electrophilic substitution. What is an electrophile? Any positive species is called electrophile. Since it is an aromatic ring, we call electrophilic aromatic substitution. So these are the special properties of fluorine. Similarly, for fluorine also, we have three special characters or properties. For example, with the potassium bisulfate, when fluorine reacts, it forms potassium persulfate. Potassium persulfate. So in this reaction also fluorine undergoes. Fluorine always undergoes reduction and it acts as oxidizing agent. Take it for granted, fluorine always undergoes reduction. From which state to which state? 0 to -1. Fluorine always undergoes reduction and its oxidation state decreases from 0 to -1 state. So whenever somebody is undergoing reduction, it acts as oxidizing agent. It acts as oxidizing agent. Now my question is, when potassium bisulfate or potassium bisulfate when it changes to potassium persulfate, which one is undergoing oxidation? Because fluorine is undergoing reduction, somebody has to undergo oxidation. If one species is undergoing reduction, the other should undergo oxidation. So here it is already undergoing reduction. Somebody should undergo oxidation. Who is undergoing oxidation? Further, the answer is not sulfur, because sulfur in both cases is +6. But here in bisulfate, all the oxygens are in -2 state. But in persulfate, some of the oxygens are in -1 state. Because what is persulfate ion? What is persulfate ion? It is S2OA minus. S2OA. 1, 2, 3, 4, 5, 6, 7, 8. So S2OA 2 minus. With 2 minus, 2 potassium ions attached. So this is potassium persulfate. What is the oxidation number of these two oxygens? They are linked with each one. O bond O. This O linkage is called peroxy linkage. That's why in potassium persulfate, two oxygens are in -1 state. The remaining are in -2 state. But if you look at, when potassium bisulfate is converted to potassium persulfate, the answer is, it is oxidation. This is one of the fluorine's important property. It is a very good oxidizing agent. Now the second property, extra property of fluorine, is its reaction. Look at this. Fluorine when react with H2S, it forms HF plus SF6. So 2HF, but SF6 means 3F2. So here sulfur is -2. 2 plus 6. It is undergoing oxidation. You all know what fluorine will undergo. Fluorine always undergoes reduction. So this is another very important point or property of fluorine. So if you summarize the extra properties that we have studied under the heading of chlorine and fluorine. So if you look at your notes, chlorine is reacting with carbon monoxide, forming a poisonous gas, carbonyl chloride, COCl2, which is also called phosgene. Similarly, chlorine also reacting with NO gas, nitric oxide, forming what compound? Nitrosyl chloride, NOCl. NOCl is also produced in which region? Aqua regia. What is aqua regia? We already discussed. 3 parts of concentrated HCl and 1 part of concentrated HNO3. Because of this NOCl, aqua regia is able to dissolve the very stable, non-reactive metals like platinum and gold. Now, similarly, chlorine is reacting with hydrocarbons like methane, forming carbon tetrachloride. It is a free radical substitution reaction, FRS. Similarly, chlorine also reacting with benzene in the presence of sunlight or UV light, forming benzene hexachloride, BHC, which is also called Ramaxin, which is also called Lindane, which is also called 666, which is a powerful insecticide. But same chlorine, when it reacts with benzene, in the presence of anhydrous aluminum chloride, it is not forming BHC, it is simply forming chlorobenzene. What kind of reaction this is? Electrophilic aromatic substitution. And similarly, some of the extra properties of fluorine I have given is with potassium bisulfate and also with H2S, with the xenon, it is formed xenon fluorides. So these are all additional properties shown by fluorine. Now, these are next to 7th or 8th property of halogens. More reactive halogen displaces So this is a very important statement. You know, down the road, the reactivity of halogens decrease. The most reactive halogen being fluorine. Next reactive is fluorine. Like that, the reactivity decreases. Since fluorine is the most reactive, if you take aqueous potassium chloride, or aqueous potassium bromide. Or aqueous potassium iodide. So fluorine can displace chlorine. Chlorine can displace bromine. It can also displace iodine. White can displace all other three halogens since it is the most reactive. So finally it displaces chlorine from its chloride salt. Similarly, it displaces bromine also from its bromide salt. Finally, it displaces iodine also from its iodide salt. Means fluorine is able to oxidize Cl minus 1 to 0, Br minus 1 to 0, I minus 1 to 0. So fluorine can displace all the three other halogens. What are all the other three halogens? Chlorine, bromine, and iodine from its salt solution, aqueous salt solution. Suppose if I take chlorine, chlorine can it displace fluorine from its salt solution? So how many of these are feasible? How many of these are non-feasible? First one is non-feasible because chlorine is less reactive, cannot displace more reactive fluorine. But second and third, these are feasible because it is more reactive. Bromine is less reactive. More reactive halogen can displace less reactive halogen. So here bromine is liberated. Here iodine is liberated. So chlorine can displace bromine and iodine, but fluorine can displace all three. Suppose if you write similar reaction for bromine, bromine can only displace iodine. It can only displace iodine. From its aqueous salt solution. Because bromine when compared to iodine is more. So what is our statement exactly? Go to the original statement. A more reactive halogen can displace a less reactive halogen from its aqueous salt solution. So this is another important property of halogens. So next property, formation of inter-halogen compounds. Formation of inter-halogen compounds. Compounds formed between different halogens. Compounds formed between two different halogens are called interhalogen compounds. For example, actually these interhalogen compounds, there are these types, AB type, AB3 type, AB5 type, and finally AB7 type. In AB type, if we react chlorine plus fluorine, we get chlorine fluoride. Like that, we can give other examples. ICl, BRF, bromine fluoride, BRCl, etc. So, what are AB type of interhalogen compounds? One halogen and other halogen, they combine in 1:1 ratio. So, like CLF, chlorine fluoride, ICl, BRF, BRCl, IF, any type, n number of types. Now, what is the type of bond present in AB type of interhalogen compounds? What is the type of bond present between Cl and F? Mr. Pranshul. R. Durga Prasad, Ahalya Kumar, Soumya, Shreya. What is the type of bond present between two halogen atoms in interhalogen compounds? Two halogens both are non-metals. So non-metal bond is always covalent.
Covalent bond.
But it is covalent, not only covalent, it is polar covalent because the electronegativity is not same for the combining atoms. In chlorine fluoride, ClF, can you predict the polarity? Which atom carries partial negative, which atom carries partial positive?
F carries partial negative charge.
Yes. And chlorine carries partial positive. So the type of bond in between the halogen atoms in interhalogen compounds is polar covalent, and the negative charge will be carried by more electronegative atom. Positive charge is carried by less electronegative atom. If you go for AB3 type of interhalogen compounds, AB type I finished. Now AB3 type. For example, you have 2 plus Cl, ClF3, 2 ClF3, 3F2. So this is AB3 type. Now in this AB3 type, chlorine is the center atom. Single atom is always center atom. Fluorines are bonded atoms. Now how many bond pairs are there? How many bonded atoms are there? That many bond pairs. How many lone pairs are there? What are the number of valence electrons in central atom? 7, NS2Sp5. Minus how many bonded atoms? 3 fluorines form 3 bonds by 2. So BP3, LP2. Total pairs are 5. Is equal to 5. When total pairs are 5, what is the expected shape and hybridization?
sp3d.
Very good. It should be sp3d. But there are two lone pairs. Two lone pairs. Three bonded atoms, three bond pairs. The central atom chlorine will have sp3d. Though the expected shape is trigonal bipyramidal, but the observed shape is T-shaped. ClF3 is a T-shaped molecule. Most important. Already we discussed about I3 minus. What is the shape of I3 minus? Linear. Just now in the same class. Now ClF3 is what shape? T-shaped molecule. And the hybridization being sp3d. Now if you go for AB 5 times, AB 5 times, I can take BrF5, bromine pentafluoride. Now this is the central atom. These are bonded atoms. What are the number of bond pairs? What are the number of bonded atoms? 5. What are the number of lone pairs? 7 minus 5, 8. 1 lone pair. So total 6 pairs. Whenever the total pairs are 6, it should be octahedral. Look at this, because of lone pair. Total pairs are 6 means sp3, p2. Expected shape is octahedral, but the observed is pair pyramidal. This is another most important point. Observed shape is pair pyramidal. Expected shape is octahedral. Why the deviation in shape in case of some molecules? Why there is deviation in shape than expected? The answer is very simple. Due to the presence of
Lone pairs.
lone pairs. Very good. Now last time. AB 7 time. AB 7 time. This is well-known example you all know. IF7. So identify the central atom. And fluorines are bonded atoms. How many bonded atoms? 7. So bond pairs are 7. What are the lone pairs? 7 minus 7 by 2, 0. Why it is 7 minus 7 by 2? Iodine has 7 valence electrons. 7 fluorines form 7 bonds. So 7 minus 7 by 2, 0. The total pairs are 7. sp3d3.
Pentagonal bipyramidal.
Right. The shape is pentagonal bipyramidal. So this is the shape. Five corners of a pentagon have 5 fluorines. 2 axial fluorines are also there. So total 7 fluorines. It is pentagonal, 5 corners, bipyramidal. Pentagonal bipyramidal. So with this, we have completed the general characteristics of halogens. If you go for a rapid revision type thing, starting from yesterday's class, first we have discussed the reaction of halogens with hydrogen. With hydrogen, all of them are forming hydrogen halides. What type of hydrogen halides? HX type. Hydrogen HF, HCl, HBr, HI. How the thermal stability is varying for hydrogen halides? It decreases from HF to HI due to decrease in
Order of reactivity.
bond strength.
Bond dissociation. HN halides dissociation energy.
Yes. HF has very high bond energy or bond dissociation energy. HI is having least. Because of decrease in bond strength, 2 other characters increase down the group. One is reducing ability, the other is Bronsted acidic strength. So which is the most powerful Bronsted acid among hydrogen halides? HI. Because H plus can be easily given by HI because of its low bond strength. Similarly, which is the best reducing agent among hydrogen halides? HI. Why? Because it can easily give hydrogens. The one that easily gives hydrogens is a better reducing agent. Then what happened to the polarity, bond polarity? And what happened to the dipole moment, water solubility? All these also we discussed. So HF is the most polar because the fluorine is more electronegative. HI is least polar. Since HF is most polar, it is having highest dipole moment. HI has least dipole moment. Since HF is the most polar, it will have very high water solubility. And HI has least water solubility. Like this, we discussed about hydrogen halides. When halogens react with hydrogen. Just now somebody has answered. The reactivity also decreases down the group. Fluorine reacts very fast with hydrogen. Even in the darkness and sub-zero temperatures, it reacts with an explosive reaction. But with the fluorine, or with the chlorine, hydrogen reacts only in the presence of sunlight. It is a photochemical reaction. Bromine requires heat also. Iodine not only requires heat but also catalyst to react with hydrogen. So that is all we discussed yesterday. But you also write one point here, note, the only hydrogen halide that exists as a dimer is HF. It is in the form of H2F2. Mention that point. The only hydrogen halide which exists as a dimer is HF. HF exists as H2F2. Now this H2F2, a dibasic acid, you have two hydrogens are there. By using a proton, form HF2 minus plus H plus. Now in one previous slide exam, JEE exam, we asked about the structure of HF2 minus. So HF2 minus has this type of structure. One HF, one hydrogen bonded fluoride. So this is HF2 minus. Now simply you can also write like this. One is a normal covalent bonded hydrogen. One is hydrogen bonded fluoride. Dotted line represents hydrogen bond. Hydrofluoride ion, HF2 minus. Here you also mention the strongest hydrogen bond. Strongest hydrogen bond in our entire syllabus is present in HF2 minus, where H is in the middle. One side is covalent bond with fluorine, other side is hydrogen bond with fluorine. Total it is HF2 minus. So with this, to conclude today's session, thank you all, and tomorrow we will further go in or further discuss some other aspects of 17th group variables. Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you, sir. रे आप रे
Right.